After all those configurations, we managed to create a working Hadoop cluster. Before we fire up the cluster and start interacting with Hdfs, I want to give you a quick tour through the Hadoop folder. I want to do that since you have touched quite a lot of files in it and maybe you are missing an explanation on how the Hadoop folder is structured. So for this, let's first bring up the terminal and log in as the Hadoop user. All right, let's make that a bit bigger. Okay, so first let's cd into the Hadoop folder. So cd Hadoop 3.3.0, and let's show the content of that directory. All right, as you can see, there is a bunch of folders in there. So what are the most important ones and what do they stand for? First, you have the bin folder, which includes all the binaries. So let's take a look into the bin folder. All right, you can use those files to actually interact with the Hadoop cluster. Now then there's the etc folder, and it contains only a single folder called Hadoop containing all the various configuration files. So let's say ls etc Hadoop. All right. The .xml files are configuration files, and the .sh files are bash files that are used to define certain system variables like Java home, which we use to tell Hadoop where to look for Java on our machine. Then there is the sbin folder containing bash files. So let's take a look at the sbin folder. And those files are used to start and stop services. For example, we've used start-dfs.sh to start our name node and data nodes. You could use start-yarn.sh to start yarn. These are the folders you will interact with the most. So there are also other folders, but the folders I've just shown you are the ones you will use the most. Now, since we want to fire up our server in this video, we will start inside the sbin folder, of course. Now, let's clear the screen, and if you are certain that you made all the configurations necessary, you can execute the start-dfs.sh file. Note that I'm currently one folder above the sbin folder, so I'm not inside the sbin folder, I'm in the Hadoop folder. However, that doesn't keep me from executing that file. So I can just say sbin start-dfs.sh and hit enter. Now it will print to the screen that it is starting the nodes, and as soon as it's done, we can check out the web UI. So it's done, and you can just click Applications, Firefox. Okay, then we can put in localhost :9870. All right, that looks good. So next we want to start yarn, so that looks pretty good. Again, we have one data node. So next we want to start yarn, and for this we need to use the start-yarn.sh file in sbin. So again, we say sbin and then start-yarn.sh. Hit enter, and it is telling us that it's starting the resource manager. Now Yarn has its own user interface, and you can reach that in the following way. So again, open up Firefox, and it's localhost :8088. Hit enter, and it will load. All right, so okay, there's a lot to check. First, let's check the available nodes. There should only be one node, of course. So it says active nodes, 1, right? But we could also click on nodes. And as you can see, we have one node over there. All right. Next, I want to show you the scheduler. So click on scheduler. And there are currently no running apps. So it says apps submitted 0, apps pending 0, etc., etc. However, note the application queues. Down there, you can see our prod and dev queue, right? So there they are. Obviously, there is a bunch of stuff you can check, and I would advise you to play around with the Yarn UI. Nevertheless, we want to start interacting with Hadoop. Now leave the Yarn UI and go back into the terminal. All right. Now enter the bin folder inside your Hadoop folder. So cd bin. All right. There's an HDFS file we can execute, so ls, you see an HDFS file over there. So the nice thing about HDFS is that it implements the Unix file system in a distributed way. Hence, we don't have to learn any new syntax. Let's say we want to ls the root directory of our HDFS. So that's actually pretty simple. You just say HDFS dfs -ls and /. Hit enter, and it's done. So let's have a look at the command. Obviously, we are using the HDFS file inside the bin folder. Next, we give an argument called dfs. So again, we're using the HDFS file, we're giving it the argument dfs. This means we want to interact with the distributed file system. Then we put in a hyphen and the command we want to execute, ls in this case. Lastly, the ls needs a path to execute on. And in this case, we just put in a / representing the root directory on HDFS. So this is just a root directory on HDFS. Now we get back nothing, which should not come as a surprise since we did not upload any files. However, let's create a simple CSV file in our home directory and load it into HDFS. So open nano and create some CSV files. So we say nano. It's created in the user space of the home directory, and let's call it test.csv. Hit enter, and let's insert some example data. So for example, name, comma, salary. Tom makes 3,000. Jack makes 4,000, and Sarah makes 4,500. Now exit and save. All right, hit enter. Now we want to put that file into HDFS. And this is actually very simple. Just use the HDFS file again. Use dfs -put. Then the name of the file you want to upload. So it's the test CSV file in our home directory and where we want to put it inside HDFS. So we just want to upload it to the root directory. Hit enter. Just wait a bit. And if we would execute the ls command again, we would see that file. So let's do that. So HDFS, dfs, ls, root directory. And there we are. Here you can see the test.csv file we have just created. Of course, HDFS supports many more arguments, and as an example, let's create a folder called test_data, and let's move our test file into that folder. So HDFS, dfs, mkdir, root test_data. Hit enter, and this command will create a directory called test_data inside the root directory. And let's move that file now. So HDFS, dfs, mv for move. And what file do we want to move? Well, we want to move test.csv. Where do we want to move it? Well, we want to move it into test_data as test.csv. Enter. Yes, of course. It's test.csv. And hit enter again. All right, it's done. Now, this command will move the file test.csv inside the root directory in HDFS into the test data folder inside HDFS. We can now run the ls command again and see that only a folder remains inside the root directory, and inside that folder we can find our CSV file. So first let's use HDFS again. So dfs, ls, and the root directory. So there's just a folder. Now let's do the same for root test data. And there it is. So this was pretty easy. Remember, we are currently working on our HDFS, just like in a production environment. The only difference is that we are running on a single node. Also, you could bring up the HDFS UI and use a graphical user interface to interact and explore HDFS. And that is actually pretty simple. So start Firefox again and go to the Hadoop UI, which is located under localhost :9870. Hit enter and click on utilities and then on browse the files or browse the file system. All right. Down there you can see the folder we have just created, and if you click on it you will see the CSV file. So click on it and there's the CSV file. From there you could interact with the Hdfs, like uploading and downloading files or creating directories. So for example, you could say download or create a new directory or upload some file. Now we have come a very long way. We now have a fully functioning Hdfs as well as Yarn as a resource manager. We've already learned how to interact with the Hdfs and we're able to interact with it. Remember that at its core, Hadoop has two functionalities. It has storage, which is represented by Hdfs, and it has compute, which is MapReduce. You might wonder why we haven't done anything MapReduce related yet. The reason for that is that we are not going to use good old MapReduce for computation. If you like data frames and your data fits into that format, I would highly advise you to use Apache Spark. Hence, in the next video, we will enhance our Hadoop cluster by downloading, installing, and configuring Apache Spark. When that is done, we basically have everything we need for our big data architecture.